This is the Data Machines Incorporated Data 620, a fully transistorized minicomputer from 1965. And right next to it here is a teletype Model 33 ASR, or Automatic Send and Receive. And these two together make a complete system, because on the Data 620 here, we've got a CPU, front panel, core memory, I/O control, and a memory power supply on the bottom. And then that can plug into this teletype, which can give I/O for the user, as well as read in paper tapes and punch out new paper tapes. So this is our input output as well as our mass storage. So these two should work really well together. Unfortunately, they're all in very rough shape. So we've got a lot of work to do to get these things up and going. This particular Data 620 was donated by Godfrey. So Godfrey, for watching, thank you so much for that. And in the previous episode, we got to work on this. This is the front panel and logic power supply for the CPU and I/O control. The core memory has its own dedicated power supply, fittingly called the memory power supply. But this was initially in very rough shape. It was really pretty gross. But after a lot of elbow grease, the front scrubbed up beautifully and looks almost brand new. The backside still has some pitting and rust here and there, but it is much better than it was, and I'm not afraid to touch it and feel the need to wash my hands immediately. There is a phalanx of spray capacitors on this thing, which a lot of you were very concerned about, but I did bring these up on the bench power supply and they seem to reform just fine. And I also threw them onto the LCR meter. Now they're a little big for the LCR meter, but the ones that the LCR meter could read checked out totally fine. So I'm not just gonna throw these in there and send it. We're gonna bring things up incrementally here and slowly add more and more load to it with dummy loads and check ripple just to make sure that everything is looking copacetic, because I really don't wanna hurt the germanium transistors in the CPU. So rest assured, we're gonna do our due diligence with these capacitors, but I think they're good enough to move on to the next step. But in that previous episode, we couldn't actually bring this up. We couldn't put any power into it. And that's because, well, there's not really a power cord that goes into the back. And we were kind of able to figure out how it gets its power by looking at the memory power supply schematic. We can see that J3 is the plug that carries all of the power up to this that will then get regulated and rectified and sent out to the rest of the systems. Now on the back, there are some unique connections, and I forgot to mention in the previous episode that I actually have all the cables. I just wasn't sure what plugged into what, but you guys noticed each of the connectors back here is uniquely keyed, which means that it should be moderately easy to find the right cable to connect the memory power supply up to this and allow us to bring both of them up together. Now, I don't know if we're gonna get that far today, but the hope is to get to work on that memory power supply and maybe throw some electrons at it. But before we do that, there's one last thing that we need to address on this front panel here, and that has to do with these big buttons here on the bottom. You'll notice that they're held in place with these little black pieces, and these are all broken. And I said in the previous episode that I'm probably gonna need to 3D model those out and print out some new ones. And Eric over at Tube Time got in touch with me and said, hey, these are the same that we've been using on Apollo gear. And so here's the 3D model file. So Eric, thank you so much for that. You're an absolute lifesaver. And because I was still building my 3D printer, I actually sent the 3D model file over to my brother, who got to work with his 3D printer and printed out a whole lot of new ones. So I'm actually really excited to get these in here. This is gonna be the first thing that we do today, but there is gonna be a little bit of work necessary because they require this kind of metal spring piece here to be uncrimped from these and crimped onto the new ones. So I'm gonna get to work on these. We're gonna get these buttons properly mounted, and then we're gonna get that memory power supply out and onto the bench and get to work on it. This little mini vise here is going to work perfectly for the job. I'll just mount the broken plastic piece in the vise, making sure that the lip of the plastic rests on the jaws. Then I just grabbed a small screwdriver and a tack hammer and slowly tapped on the metal clip until it slid off the bottom. Once one side had been removed, I just flipped it over and repeated for the other side. Those metal clips now need to get installed onto the new 3D printed pieces. I just pushed them onto the edges by hand initially, then using that same tack hammer and the mini vise as an anvil, just tapped them on until they bottomed out. With one side done, yet again, just flip it over and repeat for the other side. Give it a little test squeeze and look at how those are turning out. 3D printing is just awesome. Let's get these installed and see how they work in the actual machine. And to do that, we gotta first remove the switches, which I installed using the split and broken original pieces. Once I've got them pushed out the front, I need to pop the original pieces off. They just slot onto two little offset tabs on each side of the switch. One of these switches is a spare, not wired up to anything, so let's start with this one. And you can see the offset tabs on the left and right sides of the switch, which the new plastic pieces slot right onto. That's why they have two slots cut into them. Once all the tabs are in place, you just give the whole assembly a push and it pops right into place, looking absolutely perfect. Rinse and repeat, and now we have all of the front panel switches properly mounted. Eric, thank you so much for the 3D files, and Jeff, thank you for printing these out. They're awesome and worked perfectly. But while the plastic pieces now look and work beautifully, the switches themselves are dingy as all get out. Now that they're properly mounted though, I can just pull on the switch and the light and switch face pop right out for service. The switch face itself can slide right off of the diffuser by just pushing at it from the side. This is done so you can change the text, but it also makes cleaning an absolute breeze. I'm just using a little bit of Windex here, and ultimately I had to get a toothbrush out to really get everything clean. Also, I later realized that the clear number plate is actually a separate piece from the front face. With all three pieces now much cleaner, I can slot the number plate back into the front face, then slot that back onto the diffuser by pressing it from the side, and already that looks wildly different. Just look how much cleaner that looks now. Time to repeat the process for the rest of the buttons, and man, that came out looking absolutely fantastic. With that done, let's get to work on the real project for the day, the memory power supply. I'll slide it out, then push the slide locks in so it can come all the way out, and then make sure I lift with my legs and not my back because this thing is heavy. And finally, we'll get it up onto the bench so we can work on it. We've got the memory power supply out and it is rough. The main transformer here is very rusty. I think something was probably using that as a bit of a bathroom, and that's causing a lot of corrosion. That should mostly clean up. The transformer's probably gonna hum, but everything in this room is loud and hums anyways, so I'm just gonna let it sing its song. There is a lot of rust on the back, but that panel looks like it'll come off, so we should be able to clean that up and paint it. There's some very huge capacitors in here, like so big that they make the capacitors in the logic power supply look dainty by comparison. I'm hoping that these come up all right. We need to get them out and get them onto the bench power supply and see what they do, because they're gonna have a lot of capacity in them. I really like this tunnel here for all of the cooling fins for the power transistors, but it looks like that's gonna be a proper challenge to get clean. Well, I got to do something about the power cord on the back because it just doesn't exist anymore. So we got a lot of work ahead of us, but top tier #1 problem is going to try and get this thing clean enough that I can touch it without feeling like I need to take a shower afterwards. So let's just get to work. Let's start by getting the front panel off. It's held in place with 6 nuts on studs that stick through the backside. It's fiddly, but an appropriately tiny wrench makes quick work of it. Once all 6 have been removed, we can just slide the front panel right off. Next, let's get the slide rails off the side. They're just held in with 3 screws each and are a cinch to remove. On the back, let's get that rusty fan cover and mounting plate off. There are 4 screws around the periphery, but 2 of them don't have captive nuts on the backside, making it a bit of a pain to get loose. Now that we've got all 4 loose though, let's see if we can get this thing to slide out. And nope. Even with some decent pressure, it ain't moving. All right, let's flip this thing onto its side so we can get to the bottom. There are a lot of screws holding the bottom plate on. I didn't actually count how many, but it's a lot. With all of them removed, the bottom plate comes right off, giving great access to all the internal gubbins, as well as great access to some mouse turds. This is gross. Don't worry, I've been gloved up and masked up for the entire time, but I do need to get this thing out into the garage, which has much better ventilation, despite that making it a lot more difficult to film. Now that I have decent access and a shop vac handy, let's get all those mouse turds vacuumed up. And now that it isn't actively trying to poop on me, let's see if we can get the transistor tunnel thing out. It's still fighting me. Maybe I need to take the mounting plate and grill off from the fan itself. It's just 4 screws, but they're not captive nuts on the backside, and the plate covers them up, so it's quite tricky to get loose. But that appears to have done it. I was now able to twist it in such a way to get the loom free that then allowed me to slide it all the way out the backside. Next, let's get those big chunky capacitors out. But to make sure I get them back in the right place, I'm going to mark them with simple numbers. And then on the top of the caps, I'll number them in the same order, but also I'll add a little arrow pointing towards the back of the machine so I can be sure to get them back in the right orientation. Then I'll go through and unscrew all the wires tying the capacitors together. It looks like they're wired up as 2 sets of 3 tied in parallel. Each capacitor is held in place with 2 nuts on studs that come from a mounting bracket that wraps around the capacitor itself. Once those 2 nuts are removed, the capacitors just slide right out. There are 2 more chunky caps on the other side of the supply that need to come out as well. I just did the same procedure for them, marking their orientation, undoing the wiring, then loosening up the mounting studs, and finally pulling them fully free. Finally, let's get this regulator PCB free. It's not necessary for cleaning, but if there's anything broken, I'll definitely have to get it free to do rework. And it looks like one of the screws has been completely stripped out. I'm going to have to drill this one out, unfortunately, but that did do the trick. All right, so let's start cleaning this thing up because it's really gross. And the first thing I'm going to do is take a wire brush to the transformer. The rust on this thing is no joke, and my guess is that mouse urine is what caused this disgusting mess of corrosion, which means the rest of the power supply is probably soaked in urine as well. This is gonna look very bad, but honestly, I can't think of a better way to clean the filth off this thing. So out comes the simple green and the entire thing gets soaked heavily. Then I'll follow that up with a plastic brush, working the simple green into every nook and cranny and breaking loose the grossness. Then I'll give it a strong spray down with some highly specialized dihydrogen monoxide through a unique pressure amplification control device. In other words, I sprayed it with water from the garden hose. I actually did 2 full rounds of simple green and hosing it down, then I followed that up by placing it on our welding table out in the sun. I did an initial run with the air hose to get it dry, then while it baked in the sun, I came back every 2 hours to hit it with the air hose again, and I did this for the remainder of the day to make sure that it got fully dry. In between runs with the air hose though, I got to work on other bits, like cleaning up this front panel for example. A spray down with simple green got it shining up nice, and then for the pull handles, I hit them with a Scotch-Brite scrubby pad, which really brought out that brushed aluminum look. The main unit's still drying off outside, so I'm gonna get to work on these capacitors and check this out. I've already done one, but I haven't put any power at all into this Mallory cap. This is a 25 volt DC 20,000 microfarad cap. And you can see right now it's sitting here at like 1.9 volts with no current. But as I start to build this up, you can see we're at about 10 milliamps, 20 milliamps. As we're climbing up beyond 10 volts here, it's just behaving exactly like I would expect. This is gonna be a totally fine capacitor, I bet. And look at that, all the way up to 20 volts, pulling 10 milliamps, and if I give it a little bit, I bet you that's gonna drop down to absolutely nothing. That is, these big chonkers of a cap are probably totally fine. I'm gonna go through and do this reforming procedure with all of the remaining ones though, just to be sure that everything's looking copacetic. Now those big 20,000 microfarad caps don't do well on the LCR meter here, but this is an 8,500 microfarad cap. It's a lot smaller. So we'll go ahead and plug this one into the LCR meter and see what it tells us. Now, because it's so big, I'm gonna bring the frequency way down to about 120 Hertz here, and I'll just let it auto range on this one. Yeah, look at that. 10.8 millifarad. This is an 8500 microfarad cap, so it's actually reading a little higher than I would have expected, but I think that's a pretty good indication that this cap is just solid. One more thing we absolutely got to tackle is the power cord, and to get to that, I need to get the power switch out. And I'm gonna slice the AC power wires where they come through the case. There's absolutely nothing savable about any of this. Once cut, I'll grab the remnants from the outside and pull it free of the strain relief grommet. It put up a bit of a fight, but eventually it all came out. With the AC wires free from the strain relief grommet, I can now pull the power switch free and get clean access to where the AC wires solder in. I'll desolder the original wires after marking which one goes where, then clean up the holes on the switch, and finally solder in fresh new wires from a 15 amp extension cord I cannibalized for this. And speaking of amperage, this memory power supply supplies all the power for the entire machine. And if we look at the schematic, we can see the AC power comes in through the plug, passes through the double switch, and then goes through fuse F6, which is an 8 amp slow blow. That means that I would guesstimate the CPU, core memory, and I/O only pull a combined max of around 6 amps, or about what a modern gaming PC pulls. One last thing I want to do on the supply before we throw electrons at it is address this capacitor. It's probably fine, but the rust on it from the bracket is bugging me. Also, it's a Ducati capacitor, which sent me down a new rabbit hole. I've long known about Ducati motors, which make some of the baddest bikes around, like this Desmo Sedici RR. But Ducati Motors is part of the Ducati parent company, which consists of Ducati Motors, Ducati Corse, which is the racing divisions, and Ducati Energia, which itself is a parent of Ducati Sistemi. Ducati Energia, though, produces all sorts of electronics, even making radios way back in the day. I can finally say I own a Ducati with this little capacitor. At any rate, it looks gross, so let's get it out of here. It's an axial cap with weird flying leads coming out of it, so I'll just mark the negative wire, then desolder both and remove the cap completely. I have a new cap that's a little bigger in capacity than the one I removed, but looking at the schematic again, I think that'll be all right. It seems that this is related to the negative 12 volt rail in some way, but that Ducati cap might still be good, so let's toss it on the LCR meter and give it a fair shake. And look at that, at 120 Hertz it measures out to 1960 microfarads. Considering the cap is rated for 2000 microfarads, I'd say that cap is probably still good. There's probably still about 9,000 things wrong with this, but the best way to find those 9,000 things is to throw some electrons at it and see what shakes loose. Although I'm not actually expecting it to do anything because the power switch is on the front panel, which is also the logic power supply. So I think that needs to be feeding something back into this in order to tell this to start up. But we do have a little toggle switch on the back here that is currently down, so it should be off. So we're gonna start by just throwing some electricity at this one alone, and if nothing happens, then we'll plug in the other one and see what really goes wrong. So I'll flip the switch on my power strip on here. That nothing happened, that's good. Okay, here we go, big switch on the back. Yeah, nothing, absolutely nothing at all. That's kind of what I was expecting. All right, let's hoist this big beast out once more. All of those transformers on there make it a proper workout to move this thing around. Now I gotta figure out how to connect the two though, which means I gotta find the right cable. Thankfully I do have all the cables. I just sat down with my notes here and compared the keying of each cable. And speaking of my notes, y'all noticed in the previous episode, every plug was keyed. So I went back off camera and made this little map, which I believe fully outlines exactly which power plug goes to where. Unfortunately, I think I might be missing this power wire that connects to the core memory. But the core memory is going to be the very last thing that we mess with, so that's a problem for future David. At any rate, I found the proper cable, then sprayed a bunch of contact cleaner into both the cable and receptacle, and they slot in nice and easy. The twist lock needs to be turned about 900 times to fully tighten down, but that's coming up really nice. All right, now I'm expecting it to do something. Hopefully something good, preferably nothing bad, but let's find out. So I'm gonna flip the switch on my power strip here. Okay, nothing so far, that's to be expected. I'll do the main switch on the back here. Oh, the fan came on. That's more than I was expecting it to do. We got lights on the front. Yes. Since switch 3 is set, repeat is on, none of the power lights are on. I don't know why we've got lights on the front. Oh, if I hit the power switch, it turns off. That's awesome. I think our power supply is mostly working. How awesome is that? We have power, we have signs of life. These sense switches on the bottom are working. This thing is powered on and actually generating some voltages. Is it generating all of the correct voltages? I don't really know. The large contactor in here never budged, and I'm willing to bet that that thing is used to sequence power in a specific ways. But right now, it's not doing any of that. But it is clearly doing something because we have beautiful lights showing up here, and that is a massive, massive victory in my book. This is, I'm so excited. This is awesome. We are making really good progress. False alarm, that was just the boxer fan on the back making a terrible noise. The bearings in that thing are probably cooked, which is not surprising given the state of condition that it's in. So I'm gonna rip that one out and put a spare that I have somewhere around here. If I can't find my spare, I'll order one, but that's something I'll do in the future. Not very exciting to watch me do that. Other than that though, I mean, it's mostly working. This is like real deal legitimate progress. We have lights showing up. For today, I am extremely happy, massive victory. So I want to thank you all so much for watching, and I hope to see you in the next one.